So we continue, and you can remember from right angle triangle, if you want to get the hypotenuse, this is not new. We can remember it from a plus, a is equals, b squared plus c squared, the square root of that, if you want to obtain the hypotenuse. And this is to be valid since u and v are distances along the principal axis x and y of the space. And so the distance of a vector A from the origin is the hypotenuse of a right angle triangle. If we have an n-dimensional vector, then we get the sum of squares of those dimensions and get the square root of that. Then we can represent it mathematically as shown here, the sum of squares of the points, or the values of the points, and then the square root of that. That's how we get the vector magnitude. Next, we look at the vector normalization. We can normalize a vector by a vector, let's say vector A, by scaling it by the reciprocal of its magnitude. This produces a normalized vector pointing in the same direction as the original, which is a normalized vector, but with a unit length, that is the length of 1. The normalized vector is a vector with a unit of 1, in other words. We use a superscript hat notation to indicate that a vector is normalized. You can see, e.g., we have, as we have here, A, hat A, meaning this vector A now has been normalized. And remember, of course, the underscore shows that it is a vector. So you divide the vector itself with the reciprocal of its magnitude. That way we say you have normalized, gotten the unit. Of course, if you divide a number by itself, you get 1. It makes sense. It's a unit vector. So if we want to multiply two vectors, we can define multiplication of a pair of vectors in 2 ways. There are 2 ways, and this is important to note. We have the dot product and the cross product. The dot product is sometimes called the inner product and is comparable to matrix multiplication. The cross product takes care of direction, therefore is sometimes called the vector product, but ideally the right term for it is cross product. The dot product is actually sums the products of corresponding elements of a pair of vectors. For instance, if we have 2 vectors A and B, then if we get the dot product of A dot B, then you'll be multiplying the corresponding elements in each of those 2 vectors. A1 times B1 plus A2 plus B2, in other words, is the sum of the product of elements of corresponding elements in the vector. That way we obtain what we call the dot product. It is both symmetric and positive, and it gives a scalar value that has 3 important uses in computer graphics and related fields. First, we can compute the square of the magnitude of a vector by taking the dot product of that vector and itself. As you can see demonstrated here, that's the square of the magnitude of a vector. Then we can also compute the magnitude of one vector in the direction of another. That is, projecting one vector onto another. That is important in computer graphics. We can use the dot product also to compute the angle, call it theta, between 2 vectors. If we normalize them first, that becomes possible. This relationship can be used to define the concept of an angle between vectors in n-dimensional spaces. It is also fundamental to most lighting calculations in graphics, enabling us to determine angle of a surface that is normal to a light source. A dot B is equals absolute A multiplied by absolute B, which is basically magnitude of A times magnitude of B, and the cosine of the angle theta. The cross product, however, is not so obvious. The cross product of 2 vectors is another vector that is at right angles to both of them. In other words, is a vector as shown in this diagram that is orthogonal or perpendicular to each of those vectors. If you take the cross product or vector product of 2 vectors, what you get is basically a vector that is orthogonal to both of them. And the cross product is defined as follows. If we have 2 vectors A and B, is defined as you can see here. A times B, so there is a way in which you multiply the values with the I think I'm going to give you some more explanation, a different video showing exactly how this is done, so that you can appreciate. So in this course, we'll only consider the definition of the cross product in 3D. An important computer graphics application of the cross product is to determine a vector that is orthogonal to its 2 points. This is important. We shall look more into that. Next video we will look at matrix algebra, so that you can appreciate that the relationship also. There is a close relationship between matrices and vectors. So we have learned vectors. Now next we look at matrices. Thank you.